In this video, we're going to do two examples. We are going to deal with complex numbers and convert them to trig, and then we're going to take a complex number in trig notation and convert it back to our standard notation. So for this first example, we are going to be given a complex number, the square root of 3 minus I, which is in standard notation. And we want to be able to rewrite it using trig notation. So that means we don't want an A and B. We want to change A and B into an R and theta. And let's think about what we defined in the last video. We said we're going to know that R is the square root of A squared plus B squared, and that A equals R cosine theta, and B equals R sine theta. We also defined the fact that our notation in trig form is going to be R times the quantity cosine theta plus I sine theta. All right, so let's get to work converting. What do we know? Well, we know our A value is the square root of 3. And we know our B value is -1. So the first thing we can find is R. R is the square root of A squared, root 3 squared, plus B squared, which is -1 squared. And that gives me 3 plus 1, square root of 3 plus 1, square root of 4, is 2. So my radius is 2. The second step will be to find theta. So I need to use A and B to help me find theta. Now, we originally wrote these and we said that cosine theta is A over R and sine theta is B over R. So I'm going to write that. Cosine theta equals A over R. Sine theta equals B over R. So that means cosine theta is the square root of 3 over 2, and sine theta is -1 over 2. So now we want to think about, where does this ordered pair occur on our unit circle? Thinking about the unit circle, we always think about, our first quadrant. We've got 30, 45, and 60, or pi over 6, pi over 4, and pi over 3. When we make this, I say 1, 2, 3, 3, 2, 1, divide everything by 2, and then we put radicals in the numerator of everything. But of course, the radical, or the square root of 1, is just 1. So root 3 over 2, 1/2, occurs at pi over 6. Of course, my y value needs to be negative. So where is my ordered pair, x, y, positive and negative? And this lets me know I'm down here in quadrant 4. That's where I have plus, minus. And so what would this angle measure, pi over 6, what would that be in quadrant 4? And you should all say 11 pi over 6. So this lets me know that theta is equal to 11 pi over 6. Or we could say 330 degrees, depending on how we consider this. Right, so that unit circle logic, it's not gone. You still need to use it, and you're going to need to use it in Calc 1 and Calc 2 and Calc 3. It comes back all the time. So it's helpful, at least if you know quadrant 1, you can draw this very quickly. And then if you know these ordered pairs, you could reflect it into a different quadrant. All right, so 1, 2, 3, 3, 2, 1, divide everything by 2, put square roots in the top. So now that I know r is 2 and theta is 11 pi over 6, my third step is to use the notation. And the provided notation is that we're going to have r times cosine theta plus I times sine theta. Or rather, r being 2, and then we have cosine of 11 pi over 6 plus I times the sine of 11 pi over 6. And, depending on how we are requested to provide the answer, we could also give it in degree measure. So that would be 2 times the cosine of 330 plus I times the sine of 330 degrees. Either of those are acceptable answers. And in fact, I could use any coterminal angle I wanted. I could have said this is negative 30 degrees in here, and that would have been fine as well. Or negative 1 pi over 6 would also work. All right, let's go the other direction. Let's start with trig notation for a complex number and convert it to standard notation. So here we are given a complex number in trig notation, and we want to go back to our standard notation. And that standard notation means we want to go back to a plus bi. So what do we know? We know my r value, r equals the square root of 2, and then we know my theta value. Theta is negative 60 degrees. And of course, we could always turn that to a positive coterminal angle by adding 360 and say that that would be positive 300 degrees. All right, you could also use radian measure if you want. Just for extra practice, in radian measure, that would be positive 5 pi over 3. All of those are the same. All right, so let's find our a and b. Remember, a equals r cosine theta, and b equals r sine theta. So these are two formulas that we know. We derived them in the video before this. That would mean then a equals the square root of 2 times the cosine of negative 60 degrees. And then my b value, b, is going to be the square root of 2 times the sine of negative 60 degrees. So we just need to, again, use our unit circle logic to figure out what is the ordered pair at 60, and then let's reflect that, in this case, into quadrant 4, because this angle is also in quadrant 4. So my unit circle logic, got 1, 2, 3, we've got 30, 45, 60, and let's think about what our ordered pairs would be as I just did. 1, 2, 3, 3, 2, 1, divide everything by 2, and then put square roots over everything. So cosine and sine, remember cosine is my x coordinate, sine is my y coordinate. So at 60 degrees, we have 1/2 root 3 over 2. What would be my 60 degrees in quadrant 4? Down here at negative 60, what happens to that ordered pair at negative 60 degrees? So the x value stays positive, but the y value becomes negative. So we've got negative root 3 over 2. That lets me know that a is the square root of 2 times 1/2, and that b is the square root of 2 times negative root 3 over 2. Simplifying that, I've got a is root 2 over 2. b is negative root 6 over 2. That means my complex number in standard form, a plus bi, is root 2 over 2 minus root 6 over 2i. And that's my final answer. That's equal to a plus bi. So the point of this was just for us to feel comfortable converting between standard notation and trig notation for complex numbers, going back and forth, all right? Because you can't use them if you don't understand how to get them, create them, convert them, etc. As always, email me if you have any questions.